All right, you guys, so in the prior slide, it says that if you have a system and it has the same number of equations as variables, and the coefficient matrix, that's what we build out, is square, then it's said to be a squared system. So if the square matrix, the 2 by 2 for instance, or 3 by 3, has a inverse, which means it's invertible, then the system's going to have a unique solution. So that means it's not going to be all real, it's not going to be no solution, things like that. So we can actually find the solution to solve it by using the inverse matrix. So it actually takes a couple steps away. So what we're going to do first is we're going to go ahead. So the first step is we're going to go ahead and use the formula for our inverse that you guys learned in the prior lesson. So that's the formula. So we're just going to go ahead. I'm going to take a second and put these in the matrix. So we've got 2, -3, -1, -3, 5, and 3. Okay, so 1 over 2 times 5, that's a times d, so that's 10. Minus 3 times, -3 times -3, that's a positive 9. Which that actually comes out to be nice because that's a 1 over 1. And then we need to go 5, 3, 3, and 2, swapping them over. Well, when we multiply 1 over 1 to this whole piece, we just end up with 5, 3, 3, 2. And now we have the matrix. What we have to do is, hello Georgia, she's now in here. So now we have to go ahead and multiply, sorry about that, multiply through. Okay, so now that we've got the inverse going, we need to go ahead, we're going to take the inverse, which is a of -1. That's 5, 3, 3, 2. And we need to multiply it by this b that we call that answer in the first one in order to get our final solution. So how we do that? All right, so 5 times -1 plus 3 times 3 and 3 times -1 plus 2 times 3. All right, then you see that's -5 and 9, so that's 4, and then -3 and 6, that's 3. And so your solution for x and y is 4, 3. And that's how you solve it. It's very short compared to the other side. So that's using the inverse, and then you multiply the inverse by the b, which is that answer in the original, to go ahead and get your xy solution.